my k times my vector, which is equal to my new vector. So for example, I get my scalar k times vector a. That gives me the new vector, which is vector b. So for example, let's start off pretty slow and steady. So an airplane is heading due south at 500 kilometers per hour. The airplane's velocity is represented by vector v. We want to draw the vectors negative v, 1/2 v, and 2v, and give an interpretation for each one. So let's start with the easy one first, which is 2v. Vector 2v is just the double of the original vector. So vector 2v starts at the top, the same as vector v, and then goes all the way down, but it's double that of the original vector. So this is 2v. So if this is vector 2v, what would the plane's speed become then? (1,000 kilometers), and what direction is it going towards? Is it still going south or is it switching directions? So it's still going south. So this is equal to 1,000 kilometers per hour due south. My next one would be negative v, which is just the opposite direction of vector v. So my tail will start where the head of vector v is and go up and end at the tail of the original vector v. So this is negative v. And if I were to interpret that, what would my vector negative v state? How fast is my plane going, and in what direction is it going? So vector negative v is equal to what? 500 kilometers going north per hour due north. And last but not least, I need to do 1/2 of v. So I'm going to start over here, and I'm going to go halfway where my vector v is. So this is vector 1/2 v. So what does vector 1/2 of v give me? Thank you, Ryan. 250 kilometers per hour south. Perfect. As you can see, we're starting with some pretty basic examples, just so we don't have to, rush and worry about, doing complicated things before we even cover the easy stuff. So let's cover the basics first, and then we can move on to more challenging questions. So So we're not doing example 2 yet. We're getting into more descriptions. So for vector Ka, where K is a scalar and A is a non-zero vector, if K is greater than 0, which means if it's positive, then Ka is in the same direction as vector A and has the magnitude K times the magnitude of vector A. So if K is less than 1 but greater than 0, then vector Ka is shortened, but the direction is the same. If K is greater than 1, then vector Ka is lengthened, but the direction is still the same. However, if K is less than 0, which means if K is negative, then Ka is in the opposite direction as vector A and has the magnitude of K times the magnitude of vector A. Which means that if K is between 0 and -1, the vector Ka is shortened, but in the opposite direction. if k is less than -1, the vector ka is lengthened, but the direction is opposite. So if we have k is equal to 0, then the result of the vector is the 0 vector, which means 0 times vector A is equal to my 0 vector. So now with addition, there's also properties of scalar multiplication. So the distributive property of addition means that k times vector A plus B is the same thing as saying k times vector A plus k times vector B. M times n vector A is the same thing as saying mn times vector A, or mn times vector A, or the same thing as saying n times m vector A. And last but not least is the distributive law for all scalars, which means that m plus n times A, vector A, is the same thing as saying m times vector A plus n times vector of A. So now we have example 2. I have an airplane is flying in the direction south 50 degrees east at an airspeed of 300 kilometers per hour. The velocity for this airplane is represented by vector v. For question A, I want to sketch the vector -1/5 v and say the direction of this vector. And for vector 3/2v, I want to state its direction and magnitude. So I want you guys to try and do this by yourself first, and then I want you guys to try and give me the answer and see if you guys understand what it is that we are doing here. So I'm going to give you guys a couple of minutes to figure that question out. So if you guys don't know your directions, I will refresh you on that. North, south, east, west. So when I draw my vector, my 50 degrees is going to be from south to east. So this is going to be 50 degrees. So this would be my vector v. So now you're challenged to draw -1/5 vector v and 3/2 vector b. Or vector v, I keep saying b. So where is vector -1/5 v going to land in? Yep. So this is going to be over here. So that's going to be 50 degrees because of the opposite angle theorem, which means that -1/5 vector v. What is my new speed going to be? And in one direction is it going to go? So Muhammad gave me the direction and the angle. What is the speed of my plane going to be with -1/5 vector v? Thank you, Priyanshu. It's going to be 60 kilometers per hour. North, 50 degrees west. Now for the next one, I don't have to draw it out, but I need to figure out what 3/2 vector v is. So who can tell me my speed and the direction that this thing is going if vector v is multiplied by 3/2? It's going to be 450 kilometers per hour. South, 50 degrees east. Perfect. As you can see, pretty simple stuff so far. So now we can move on to our next example. So let me just scroll down. So now we're going to be talking about collinear vectors. I was going to say vectors, that was not bad. So collinear vectors, the same thing as saying parallel, are two vectors that are parallel or lie on the same straight line. Essentially vectors which can be translated so that they lie in the same straight line are collinear vectors or parallel vectors. They do not have the same magnitude, but their directions must be exactly the same or exactly the opposite. So more formally, two vectors, vector u and v, are collinear if and only if it is possible to find a non-scalar zero, k such that u is equal to k times v. So now we're going to get into something called a unit vector. So a unit vector is a vector with a magnitude of 1. For example, if vector u has a magnitude of 6, then 1 over 6u will have a magnitude of 1. So what this means is that I'm going to be denoting vector u. So unit vector u is equal to 1 over the magnitude of vector u times vector u. So for example, if I have my vector u, which is over here, let's say this is vector u, and I have the magnitude of my u is equal to 6. My unit vector will give me a magnitude of 1, which means that the magnitude of my unit vector is equal to 1 over 6 times 6. So the 6's cancel out, which gives me a unit of 1. So in this case, I would just write unit vector u is equal to 1 over 6 times my vector u. So the u hat equals 1 over the magnitude of u times vector u. So u hat points in the same direction as vector u. So we're going to take examples to show where this is applicable. So basically all we're doing with that is we're showing that we're taking a parallel vector and showing that a unit vector can be written with the same magnitude of 1, but it's also going in the same direction. So example 3 is going to show us exactly what that is. So I've given the magnitude of u being 8 and the magnitude of v being 3, and the angle between u and v is 120. Determine the unit vector in the same direction as vector u plus vector v in terms of u and v. So I'm going to start with my drawing. This is my tail. Vector v is going to be going this way, and vector u is going to be going that way. Which means that this angle over here is going to be 120 degrees. So I can draw my other vectors as follows. Okay, and I'm going to take my parallelogram, and I need to find my resulting vector, which is vector u plus v. However, because we want to find a unit vector, let's let vector u plus vector v equal to vector w. Okay, so I have my magnitude of u is equal to 8. My magnitude of v is equal to 3. So I know my one obtuse angle is 120, which means this acute angle over here is going to be 60 degrees. Now, because u plus v is equal to vector w, I can therefore find the magnitude of w squared is equal to 8 squared plus 3 squared minus 2 times 8 times 3 times cos of 60. Again, we're just using cosine law, which gives us 64 plus 9 minus 48 times cos of 60, which is 1/2, which gives me a result of 49, which means if I square root both sides, I get the magnitude of w is equal to 7. Perfect. So now I can find u plus v in terms of a unit vector. So I need to find, so I know w, or hat w, is equal to 1/7 times my vector w. However, we know w is equal to u plus v, which means that my unit vector for u plus v is going to be 1/7 times vector u plus 1/7 times vector v. So that would be my unit vector for u plus v. Now, I need to find the angle that is relative to u. Okay? So what I mean when it's relative to u, I'm finding this angle over here, because u is my adjacent angle to that side. So now let's find it relative to u. So again, sine theta over 3 is equal to sine 60 over 7, which gives me a theta value of 21.79 degrees. And this would be relative to vector u. So therefore, I have determined my unit vector. I've determined my angle in respect to vector u. So my final statement is going to be, therefore, the unit vector w is equal to 1/7 times vector u plus 1/7 vector v, which is 21.79 degrees relative to vector u. Again, all we're doing here is using cosine law and sine law to help us figure out our solution. So I have the vectors x and y are unit vectors. So x and y are already unit vectors that make an angle of 30 degrees with each other. Determine the vector 3x minus 2y, both direction and magnitude of the vector. So I have my unit vectors here. I have unit vector which is x, and I have my unit vector which is y over here. Okay. I need to determine the vector 3x minus 2y. So this is a unit vector y, which means that I need to figure out what negative 2y is. So my new drawing is going to have minus 2y go the opposite direction. This will be negative 2y, or vector negative 2y. And then I have 3x, which is going up here. So this is 3 times vector x. And now I need to find the resultant. I need to determine the vector, which is the resultant of 2x minus 2y, which is this resultant vector over here. (3x minus 2y). However, I know that my unit vectors make an angle of 30 degrees with each other. So if I were to extend this over here, these unit vectors make an angle of 30 degrees, which means this guy over here, we follow the Z pattern, makes 30 degrees as well. So based off the magnitudes, I know that the magnitude of x, because it's a unit vector, has to be 1. And the magnitude of y has to be 1 because they're both unit vectors, which gives us a value of 1. However, because I want to find 3x minus 2y whole squared, all I need to do is take the magnitude of vector 3x squared plus the magnitude of negative 2y minus 2 times the magnitude of vector 3x times the magnitude of vector 2y times cos of my angle, which is 30 degrees. So because they're magnitudes, I'm left with 3 squared plus 2 squared minus 2 times 3 times 2 times cos of 30. So I'm left with 9 plus 4 minus 6 root 3, which gives me 13 minus 6 root 3. Now, if I square root both sides, I get the magnitude of 3x minus 2y is equal to the square root of 13 minus 6 root 3, which gives me approximately 1.61. So now I need to figure out what my angle is going to be. So this is going to be the angle that we're finding over here, which is theta. So I'm going to take sine theta over 2 is equal to sine of 30 divided by 1.61, which means theta gives me approximately 38.26 degrees. So now I can find my therefore statement. Therefore, therefore 3x, magnitude of 3x minus 2y equals to approximately 1.61 units, 38.26 degrees relative to my vector x. So like I said, or what we started off with, is I'm going to draw this, was our unit vector. So I have, this is vector x originally, and then this would be my unit vector y. Okay. The reason why negative 2y is going the opposite way is because when I have a negative scalar, I'm just moving in the opposite direction. And 3 times the vector x just means I'm taking my unit vector x and multiplying it by 3 times. And the reason why my top right angle is 30 is because it says vector x and vector y make an angle of 30 degrees with each other. And last but not least, we're going to determine or examine the collinear vectors in the diagram. So for question A, I want to express vector B and C as a scalar multiple of A. And for part B, I want to express A, B, and C, each in terms of a unit vector A. So basically what I need to do here is I need to figure out how I'm going to write B and C in terms of A. So in order for me to find the magnitude of A, I need to figure out what my resultant vector is. So this is 1 and this is 2. So for question A, I know that vector B is equal to K times vector A, and vector C is going to be K times vector A, which means I need to figure out what is K. So the magnitude of A, again, this is just Pythagorean theorem, is going to be the square root of 2 squared plus 1 squared, which gives me the square root of 5. Which means that my magnitude of vector A is going to be root 5. So this is going to be my starting point or my reference point. Now I need to figure out what the magnitude of vector B is, but I have to make it in terms of a scalar of vector A. So again, if we do the same thing, let's take a triangle. That was a terrible, terrible drawing. So I'm going to take my triangle here, go up. This is 5 and this is 10. So the magnitude of B is the square root of 5 squared plus 10 squared, which gives me the square root of 125. Now, since I want to make it as a scalar in terms of vector A, I need to rationalize my radical. So I can turn 125 the same way I'm saying 25 times the square root of 5, which gives me 5 root 5. Okay, so B is 5 times the magnitude of A. Now we need to do the same thing for C. So again, make a triangle. Even though it's moving in the opposite direction, so the magnitude of vector C is equal to, this is 3 and 6, is the square root of 3 squared plus 6 squared, which gives me the square root of 45, which means I can rewrite this as the square root of 9 times the square root of 5, and this gives me 3 root 5, which means that vector C is 3 times the magnitude of vector A, except it's just going in the opposite direction. Okay, so I can rewrite this as vector B is equal to 5 times vector A, and vector C, because it's in the opposite direction, is negative 3 times vector A. So now for B, I want to express each one. So I want to express A, B, and C in terms of a unit vector. So using the information, I know that the magnitude of A is equal to root 5, which means that the unit vector A is equal to 1 over the magnitude of vector A times vector A. So this gives me 1 over root 5 times the vector of A, which means vector A, if we were to arrange it, is equal to root 5 times the unit vector A. So now we're just going to use what we used for our conclusion in A. So I know vector B is equal to 5 times the vector of A. We found out from B, using our unit vector, that vector A is just root 5 multiplied by the unit vector. So this would give me 5 times root 5 times a naught, which gives me 5 root 5 a naught. And then I'm going to do the same thing with vector c. So I know vector c is equal to negative 3 times the vector of a. So using what we found, we got negative 3 times root 5 times the unit vector a, which gives me negative 3 root 5 unit vector a.